Talk without any further ado over to you now. Thank you.
Hey, thanks a lot for the introduction. Yeah, hello everyone. I'm gonna be sharing my screen now, and yeah, like we said in the beginning, you got questions in between. Please feel free to ask those. So we'll take few while we move, and then we'll cover rest towards the end. This is to make sure that I get time to finish everything. I'll try to answer as many questions as possible. Anything I cannot answer, I'll see if there are other mediums to connect with you guys and answer those questions. That said, let me share my screen and get into the presentation mode. Okay, yeah, so like uh, they already shared an introduction about me. So adding to that, why am I covering this topic, chatbot building, conversation building, right? So in my previous art around 2017, we used to build, like I was part of a team that was building a dialogue management system and that allowed the customers to build really complicated chatbots. Uh, so we did build a really great solution, but it used to take a lot of time. And to be honest, we sort of optimized that flow back in 2017 by building this system, this platform to let them build faster fast. Before that, it used to be worse. People used to hand code the bot, right? Like every single use case was coded and integrations and all. It used to take months to get something live. Now, even though the dialogue management systems improved it, they were still taking decent amount of time, and there were limitations around uh, the models understanding and uh, the confidence of the model. Right, with LLMs getting popularity after GPTs being released in November 2022, I think it got very popular. Everyone knows what LLMs are capable of. Now building the bot is very simple, like pretty fast, but it comes with its own challenges, right? Because these bots can do so much that you sometimes have to stop them from doing certain things, right? Because once you deploy something, it represents a brand. So that's what we are going to be covering today. We'll talk about how the bots were built earlier, like some common terminology and the internal details with classification models, how those were built. Then we'll talk about how those are built now with the LLMs, right? We'll talk about some scenarios when both these things can be used together to give better results. We'll also talk about scenarios where LLMs might be problematic and classification model or some other solution might be a better choice. And then we'll also spend some time towards the end where I have built some bots on my local, like one chatbot using classification model, and then one or two using the LLM. We'll play with those and see what I mean when I talk about the different concepts throughout the slides. We'll see some of those things in like with examples towards the end. That said, we'll start with the common term. Like before we get into the terminologies and all that, I think it's important to understand where are the chatbots used, right? To like, do they really add any value in real world? One thing I want to clarify is even though I'm saying chatbot, doesn't mean it's always chatbot, right? It can be through other mediums as well. Like sometimes we call a 1800 number and there's an IVR bot that will listen to the questions, route it to you to the right queue and all. That's also built using similar technologies. Sometimes you might use Google Home, Alexa, different IoT devices, right? So even though the user interface might be different, like taking the input, processing it, but the underlying system that will identify the user intent, perform some action, it's pretty much common between these systems. Right? Now, talking about the scenarios where these chatbot or conversational bots are useful, I think customer support is a very strong use case. Everybody has been using it for a long time, right? Uh, like it's very common. Every time we face a issue with booking or refund, we call a 1800 number. We spend 1 hour waiting, then 30 minutes talking to the customer care agent, right? And and in most cases, the problem is solved. In many cases, it's not, right? Now, think about that. Like so much time is spent, like one hour, 30 minutes for one problem, that too with 50% success rate. Automating that with chatbots is very simple because first, there's no wait. Chatbots are available all the time throughout the day. All those manual operations they do and make mistakes can be fixed with API integrations, right? So that's one of the most common thing and very commonly used in the industry right now. Uh, Sorry, I jumped few slides. Yeah, the other use cases I'll quickly cover is healthcare. Yeah, healthcare is very important. Like there are a lot of things we do, like basic stuff, calling to schedule an appointment, and routing to specific departments and all that can be automated with chatbots very easily. Finance and banking, again, a really good example. Like a lot of repetitive things we call, hey, what are the offers on my credit card? Why there's an extra payment? And then these details can be very easily automated through chatbot. E-commerce, I think it's used very broadly in e-commerce, and I think it has a lot more potential than what we do. Like, for example, not just the processing order and then refund and all those scenarios can obviously be automated through. The other very helpful scenario is recommendations and finding the product. Like, think about it, like you go to Amazon, Walmart, Target, right? Like there's like pages and pages of description of every product, and then there are customer reviews that will have the right answer. If you build a right chatbot, right, it can actually go through the product details, it can go through the customer reviews, find the question that you're asking, right, and give you a response. And these are just few items that I'm listing here. There are a lot more. So again, like I think any business that is online will need chatbot either now or later. So that said, let's start with some basics. We'll not spend too much time here, but just to make sure everyone understands what are the terminologies we were using for traditional chatbots. First is intent. Intent is nothing but the user goals. Like what are you trying to do? So when I say that, hey, I'm trying to book a flight from San Francisco to New York on September 13th, then my intent is book a flight. Yeah, because that's what I'm trying to do. The next one, entities. Entities is the piece of information you need to complete the intent, right? For example, in the last example, the source city was San Francisco, destination was New York, and the date of travel was September 13th, right? Then dialogue management. Dialogue management is a system that controls the flow of conversation. Now it's very important when you build those multi-turn flows, right? Like booking a flight and all, it has so many steps in it. Like you have to collect the travel date, travel detail, show all the options, collect passenger details, then select the option, then collect payment details, process the payment, seat selection. So many things that you want to go like step by step, right? Maintain context in between all those flows. Dialogue management systems are very helpful in defining those flows and executing those. The last one is intent classification, which I would say is the most important one. Intent classification model is just a machine learning model that will take user input and then categorize it into one of those predefined intent categories, right? Like when I said I want to book a flight, it means it's a book a flight, right? When I say how do I return my package, it's like return order, the category. Now there are several types of models, like some of the listed SVM, decision tree, RNN, and all can be used. And depending on the your use case, you can decide which one is a better choice. Nothing new on this slide. Like I said, classification model is that you have a machine learning model that will take your user queries as input and inform what the output is. The thing to note about a classification model is it works in a way where you collect a lot of data, right? And you label the data. So if we spend a few more minutes figuring out how these models are built. So look at this, like these are the steps, very high level steps that are required to build a classification model. The most time taking process is data collection. Like if you are building a classification model that can handle the e-commerce scenarios, right? You'll have to identify every intent you want to handle, like return order, refund, order status, and any other scenarios. And then collect user utterances or user queries for each of those, put it in a file, right? And tag all of them that, hey, when someone says this, it matched to this intent, right? And if you want to build a really strong model that understands most of the variations of the user queries, you got to collect more and more data, like maybe 100 or more intent utterances or user queries for each intent. So we collect those, put it in some sort of file or storage, right? We do some pre-processing on those, extract some features, select some models, right? And then train the model. Now, training the model is, again, a computationally expensive process, but depending on how big a data size is, it's gonna take some time, right? Like when we used to build it, it used to take like 30 minutes to few hours, depending on how much data are we training. And like towards the end, I'll also show you one working example where I will have some data collected for e-commerce use case. We'll build a model with that small data set and then use that model to run some, like build a bot. Now, every time models are built, there's a good amount of time spent testing it, evaluating the model, making sure it's actually doing the job, right? And then you deploy it in one place and expose it to a bunch of APIs that can be used to actually interpret intents from the user input, right? Pretty much similar setup is used to identify entities as well, but those models are different. Those are the NER models, not the classification models. On the other hand, large language model, I think everyone in this webinar will know about this. You guys have keen interest in this field, right? So large language models are pre-trained models. They know pretty much everything. Like all these steps I was showing about in previous screen that, hey, you have to collect data, pre-process and all this is done. It's a built and deployed model that you get. Right? And you can ask anything. Consider it to be like a really, really smart person who knows everything, right? You can talk to him about anything. Like you can ask, what is the best place to visit in Italy? It will give you an itinerary. You can also ask some philosophical question like, why is the sky so blue and all that, right? It will give you some answer. It will understand what you're trying to say. No need for training. Let's talk about some terminologies, even though most folks will know about this, right? But this is what you do. Like when you are building a bot, you will be dealing with these. The first one is prompt engineering. I want to talk about. Prompt engineering is nothing but talking to your bot. Like the way I'm talking to you guys, I talk to some other person. You can talk to your bot and say that, hey, you are the bot, chatbot for this brand. Answer the user queries based on this data I'm giving in the context. Be polite, be friendly, all these details, and then your chatbot is ready to start answering the user question, right? Like if I have to choose a real world analogy, right, I would say, let's say there is a real hospital, like Kaiser or someplace, right? And physical hospital. You hire a really smart guy for a front desk job, right? What do? You just come take this person and say, hey, you are the front desk representative. Here are the FAQs. If someone asks this question, do this, right? If someone says they want to get the blood work done, send them to laboratory. Someone says they have blood pressure issues, send them to cardiology, right? And then be polite, be friendly. That's it. You can hire that person, right? You put them, let them sit on the front desk, see how he's doing for a few days, ask him to improve, and that's it. That's how prompt engineering works. Like you talk to the bot, you tell it what to do. However, it can only work for things that can be communicated through words, right? Like maybe front desk job, even though I'm trying to oversimplify things, but front desk job is okay. But same thing you cannot do with doctors, right? You can't take a physician and say, hey, from now onwards, you are a surgeon. Right? Here is the FAQ. If someone says blood pressure, give them a bypass surgery. It doesn't work that way because it needs rigorous training. Like you have to spend a lot of money, you have to go to college, right? Understand the domain specific data, and that's when you can be a specialist. The same thing goes with fine tuning. If your use case demands understanding of a lot of domain specific data, right? Like really specific scenarios, which is not very publicly available. Models are not trained on those. In those cases, you're gonna collect that data set, like all those different questions people say, how does the journeys move, right? Collect that data and then train the model, right? Train them again, and that's called the fine tuning, right? Similar to the doctor going to a postgraduate course to be a specialist. Retrieval augmented generation, RAG. RAG is like it's very simple. Like not every query is going to be static, right? You want some of the queries to look into the databases and find the response. Right? For example, baggage query. When I say, hey, what's the baggage policy on my flight? Then depending on the category of travel, if I'm traveling economy, there are different rules. If I'm traveling business, there are different rules. All this information might be in some database. So if your bot can look into the database and find out the right response, that will help the user, and it's going to be very scalable setup, right? So that's what it does. Like you store the data knowledge base in a specific format, and then you retrieve it, this information, augment it to the response, and send it back to the user. The last concept we'll briefly talk about is agentic workflow. Agentic workflows are like similar, like when you have a complex task, right? There are so many things in that. Then you might want to break those into smaller agents and then let them handle a specific task, right? More manageable steps. Uh, Similar to, and I'm gonna look at the questions in 1 minute, see if there's something quick I can answer right now. Like, so similar to the way I was showing you guys that, hey, you have to train the model, right? The classification model. Similarly, when you get a pre-trained LLM, right, it has these, like all this step data collection, pre-processing, model training and all, it's all done. You get it. When you open OpenAPI.ChatGPT or Gemini.Google, that model is already trained with all this. If your use case demands fine tuning, then you got to collect the data, process it, and perform fine tuning. In almost all cases for chatbot, you're going to be using prompt engineering to tell your bot what to do, right, on this fine tuned model. And you're going to test those prompts, optimize the prompts, and then deploy. This is your deployed model, which is ready for consumption. Now, again, user queries come, they are going to be pre-processed, sent it to this particular LLM with optimized prompt. It's going to respond based on that. So training LLM, yeah, I mean, we talked about this, right? When you are trying to build a bot through LLMs, you want it to be trained to your specific domain. So your use case might be e-commerce, airline, a hotel, a healthcare scenario. So you got to prompt the right prompt, like craft the right prompts to tell your bot what to do, like give it some context to work on. Integrate with the knowledge bases, like all the databases you have where you have information about the order details and all connected with those. And then it requires fine tuning, right? Now, this is very generic concept. We'll build something towards the end through this, and you'll see what I mean, like, and how simple it is to build a bot with this. That said, yeah, okay, let's compare this as well. So that like between classification model and LLM, right? So if we like think about this, like building a classification model, you have to go collect all the data. You have to label the data, right? You have to put decent amount of effort to get something working. However, if you know your data set, right, then it's gonna be very efficient because it's a small model. It takes less time to execute. It's gonna respond with the categories of data that you want to handle, right? So it's very good for a specific task, very efficient. You understand what the results are. However, it suffers with the like the flexibility, right? The user have to stick to a script, like the type of data you trained it with. If they're saying something around that, your bot will answer. Otherwise, they'll not be able to understand what the user is trying to say. And yeah, there are some examples we'll talk about. Like users get, like very innovative with the questions, right? And then classification models used to fail unless they are trained with huge amount of data. LLMs, on the other hand, they are pre-trained with huge amount of data. We don't have to worry about giving them different utterances and all to train. Right? And the one of the really good things with LLM is the response generation. Like classification model just identify the intent, but LLMs can actually generate the response. Now, which is a big deal because the response they generate is super awesome. Like forget about chatbot. For every use case, I know people use it. Like they refresh they write something very basic and send it to LLM and say, hey, refresh this in this format, make it professional, make it funny and all, right? And you'll be surprised by the output that LLM will give, right? So using that for chatbots, it makes your bot look a lot more like the user rather than being a bot, which just says to static words, right? On the weakness side, LLMs are like computationally expensive, right? Because it's a huge model that you have to execute every time. So, and the latency is also high compared to this one because it's a bigger model, right? Like compare it like driving a truck versus driving a car. Right? So LLMs are huge. They take. I'll not talk about other things. Like this is like you're trained on a specific data, so you are biased towards the data they are trained on, right? That might not align with the domain that you are working on. So that means, like at a very high level, if I had to say, I can say that, hey, if you have dedicated, well-defined task and labeled data, then classification model will be faster and a better choice. But if you have like open-ended task, you have like you don't know how you just are going to be framing those questions. LLMs are always going to outperform classification models in terms of accuracy and response. Let's quickly see if there is any question that we need to answer. All right, so good. I don't see any questions here. I'll continue, uh, and if there are questions, then moderators will stop me. I have decent amount of other material to go through, so no need to take a break, right? So now when we know the concept like LLM and classification model, right? Now let's talk about the chatbots, which we said that we are going to be building. Now chatbots, usually there are two high-level categories of queries that we handle in chatbots, right? One is the single turn response. You say something, you get a response, right? Like I say, what are the store hours, right? How do I return this? Sometimes it doesn't mean that uh, it can be like it has to be single turn means it can also collect some information, make some API call integrations and all, but still it won't be multiple steps, right? So which will fall into the FAQ category, and the other category is multi-turn, like multi-step journeys, like booking a flight and booking an appointment for medical appointments and all. So talking about FAQs, like if you are building an FAQ with classification model, right? All you have to do is train your classification model, collect the data, train the model so that your model can identify the intents, and then configure a static response against each of this intent so that when your model says that here's the intent, you can look for the response and respond with that. So yeah, I have a bot that I have built on my local laptop. I'll be showing you guys how to like some data set that I'm using. We'll build a model. I have another sheet with the static responses. It will execute the model, choose the response from that, and send it back to the user. Uh, and then the complicated, like somewhat complicated scenarios when you have to make an API call or perform a database lookup and all, that can also be done, right? The only thing is when you call an API, you get some data, you have to show it back to the user. That becomes somewhat tricky because the responses were static, right? So we were using the templated responses where you put placeholders, right? Like you say your order with this number is currently at this location and all, and then the order number location can be coming from the database API call. That's how we generate the response and send it back to the user. So it used to work. It was doing great, right? Uh, Pros are like works well. Like if you know what you are doing, your use cases limited, like really fast, low cost, low latency. However, on the con side, every now and then some users will not say their standard words, right? Like I like for example, this use case, you want to know how is the weather tomorrow, right? And somebody comes and says, hey, should I carry an umbrella tomorrow? Now, the bot can answer only when they are trained with something like this. Right? But LLMs are very smart. Like if you ask this to LLM, it will know that you're trying to ask for the weather. The other thing is manual updates. You review your bot transcript, you find out that it's not handling these scenarios. You want to go update the data set, build the model again. Right? So that it's a like recursive improvement process. And this dynamic integration, like I said, you call the API, get the response, you're putting it in placeholders. It it gets complicated to maintain. Like even though you can do it, the responses are not that innovative, like compared to what LLMs can do. Uh, on the other hand, FAQs like with LLM, very simple, right? Like just like because it will identify the intent and give a response automatically, right? So all you have to do is like give it some data through prompts, like give it maybe a list of question answers that for these questions here's the answer, right? Or like give it some context that here's the context about the work we are doing through prompt engineering. and then that's it. It can work, right? If you want to integrate it with knowledge base, which I'm pretty sure you will in some cases, right? Then like organize your knowledge base, write those integrations with the LLM. Some work here, but pulling something like this is very easy compared to pulling the traditional classification based model. Uh, Training the LLM, yeah, if you have to fine tune and all, then consider these options as well. The other thing with LLM is like you don't have to just maintain one bot for everything, right? What you can do is like, for example, your data source, it won't always be uh, in one source, right? And then you have to define all that in a specific format. With the with the recent advancement, like what you can do is you can create multiple bots, multiple multi-agent setup, right? And one agent can look into database, one can crawl the website for FAQs, one can look for a spreadsheet, right? And then you can write some sort of routing that depending on the question, you can route it the right LLM agent that is trained to process that type of queries. So it gives you a lot more flexibility to handle different cases, right? Uh, Now both are good, right? LLMs are obviously work, right? So what is the hybrid approach like? Is there a recommendation? And that's what we'll talk about now. So in my opinion, right, when you are building a chatbot, you want to be careful and know like what are the scenarios you want to handle. Like you will know that these are the 200 intents I want to handle, 200 type of journey. Classifications models are very helpful there because those categories, right? Some of those might require very simple static responses. Some of those will require like complex operations like integration with data source and all. So what we can do is that like following up on that multi-agent setup, you can have different LLM for different categories of FAQs, right? And then can have the classification model that will first classify the intent, and depending on the intent, it's going to route it to the right LLM, which can handle it. The straightforward answers like store R's and all, they can be static answers. It will handle those, right? And then there'll be cases where the classification model will completely fail, right? It won't even be able to categorize the intent. In that case, you can always file back to a generic LLM that will search through the entire knowledge base, right, and find the answer. Now, this is a production example like that happened in the previous job that I was in. Like, even the user says, I need help with this 215, like classification model has no idea what this is, it fails, right? But you pass it to LLM could figure out that it's a tire model, right? Now, classification model could have done it if it was trained with this data, but consider like you were using Costco, like building a bot for Costco. In that case, if you were like LLM will tell that, hey, this belongs to tire and all, and we could have routed the query to the Costco tire bot to handle this, right? So now that's one basic thing that, hey, always start with classification model, let it route to the right LLM, right? But there are other scenarios. That's not the only one where I think LLMs might be problematic, right? And classification model can help. One of that scenario is fine tuning, right? Like I have been saying, fine tuning is expensive, right? Not something everyone would like to do. And then not every model supports fine tuning as well, right? Like I think GPT 3.5 and GPT 4 did not support fine tuning. I think I got a mail like 2 days back where GPT 4 is now going to support fine tuning. But even if they do, it's going to be very computationally expensive. And as an alternative, right, if your use case requires very domain specific data, right, like for example, symptom analysis for healthcare or doctor prescription reviews, right, or complex banking offer, you can train classification model to detect the intent. Like collect all the data that we have, train the model to detect the intent. For response, we can still use LLM. Right? So you identify the intent here, then that intent with some information, send it to LLM, and it is gonna give a human-like response. So that's one use case. The second one is, and I think this is very important to note, is the data handling, data privacy issues, right? So if your chatbot requires handling PCI data or things around that, right? Now there are very strict data storage requirement about that. Like PCI DSS, it says you can't even store CVV, even for like it should not go to disk. It has to be in main memory for a fixed duration and has to be deleted after that. If you're using some hosted LLM, right, from some provider, then you don't know where your data is stored, what are the different hops, if it's going to some logs or some samples, right? And of course, you can do research and find out if it's still feasible. But if those scenarios are simple enough, right? Like if somebody is trying to find out the offers on the credit card and they still have to give the credit card number, those things can be handled through classification model, right? So that's another good scenario. Like be careful about these sensitive data scenarios and carefully choose which model to use there. Uh, then let's check for the questions again. Then all right, yeah. And then I just have few more slides, and then we'll start playing with the bots that I have built, right, and take more questions then. So we talked about FAQ bot, which is like one turn. You ask a question, it does something, gives a response. Multi-turn bot, on the other hand, are complicated, right? They have like several steps in it. For example, the first example that I took in the beginning was the flight booking, right? Now I have some steps documented here, and these are not even all the steps, right? It says first the user will say, I want to book a flight. It will say, oh, it's a flight booking journey. It will go here, right? Collect all the flight details, show all the flight options, let the user select the flight, then it's going to collect the passenger details, collect the payment details, process the payment. In some cases also, uh, like uh, allow them to select seat and meal and all. So it's a pretty multi-step complicated flow. If we really want to build this, right, then and there are like people are building this, right, then dialogue management system had been very helpful for doing so. Like that will help you route that journey in this direction, maintain the context in between, right, and help. In the current setup, I think if you're building something new with LLMs, I think LangChain and LLM are a very good option. They are probably better than the standard dialog flow systems, right? And then this multi-agent setup, it also works with dialog systems now. Like they're also allowing these agents. Like every one of these steps that you think your standard setup is not able to handle easily, you can rewrite that in the LLM-based chatbot, right? LLM-based integration, and let it handle those scenarios. Even in this case, the initial routing, I think classification models will do a better job, like because you know the type of journeys you support, right? You can't support every single journey in the world. So using classification model to identify the intent and routing to the correct journey, that will be a good way. The next one is interesting. I mean, I don't know, you guys would have heard like there are scenarios when now people are building chatbots through large language model and deploying this. Even the users know that these bots are built using large language model, and they are like configured to be helpful, right? Like keep the user happy. So what people do is they try to trick the bot. Like for example, they'll try to get the cancellation fee waived off. They'll try to get a better deal, right, through chatbots. And if your chatbot agrees to any of that, they'll say, hey, your chatbot said they are doing it, and now I need that deal. Right? So let me give you one example. Like, so let's say you're building an e-commerce chatbot, and you have a return policy, and the user says, hey, can I return something after 30 days? The bot will say, no, you cannot, right? The policy is 30 days, within 30 days return. Second question, the user might ask, hey, can I return the item in original packaging? And the bot will say, yes, that's recommended, right? Return in the original packaging. Then the guy will get innovative and say, can I return the item in original packaging after 30 days? Right? And like multiple such variations to confuse the bot. And at one point, the bot will confuse and like it will ignore that 30 days part and say, yeah, sure, you can do that. And then they'll say, come back and say, hey, I kept the item with me because your bot told me that I can return it after 30 days. So that creates conflict. I think I don't know the exact name, but there was a case where one chatbot for one airline sort of waived off the cancellation fee for one user uh, with similar scenarios, and then the later airline said, "Oh, we cannot do it because it's not allowed, right, against our policy." And there was a big argument. I think that he also sued that person. At the end, the airline ended up paying the cancel. Like they had to agree to it because once you deploy your chatbot, it represents you, right? That's what, like, this is your chatbot, this is what you're doing. Yeah, so that happened. So that's why, like, it's important when you're building your chatbot, right? Like, when you're giving prompts and all, sort of, like, follow the tricks that will ensure that people cannot, like, I know there are a lot of development, a lot of work going on in the LLM industry, like those models are also trying to avoid such things. But what will help is, like, if you are passing the context, all the chat context to your bot, right? It can figure out that, oh, the user is trying to rephrase the same sentence again and again, right? And then in those cases, it can call back to an human agent and let it handle those scenarios. So those are the considerations that we got to have when building chatbots through LLM, right? Building fast is one thing, but yeah, I think it's important because once you deploy it, your chatbot, it represents you. Anything it says, right? It will be, you'll be liable for that. And believe me, these chatbots are trained on huge amount of data. They can answer pretty much everything. Data privacy is again follow up of what we talked earlier. Uh, the chatbot is handling sensitive data. You got to know where it's stored, right? If you are using, like, deploying your own chatbot in some service, you'll have better controls, like Gemini and all. You can deploy in your own cloud service. But if you're not, right, like deploying using a hosted service, right, then you got to be careful about these. I think after this, I'm going to be moving to demo where we are going to be playing with some chatbots and like seeing some of these theoretical things I talked about in action. Before I go there, I'll see if there is any question that you guys have right now. I can take a few right now and then others towards the end. Right, so questions are there. Looking at the questions in this screen. Yes, I think someone is saying resources, right, for training the model. You're right. Yeah, it's not an easy job, right? Uh, and retrain doesn't mean they're gonna be retraining every single thing. Like, I don't want to go into the internals of fine tuning, but it sort of works in a layered structure where few parts of the models are trained and then both are combined together. And so it's still doable, but again, very expensive work to do. How would a chatbot know when it couldn't answer complex question and thus escalate to human agent? Point on that always generate results. Yeah, exactly. So great point, right? How will a chatbot know when couldn't answer a complex question? So that's something you'll have to tell your bot through prompt engineering, right? Or maybe write some custom logic in between that says, hey, so like if the user keeps asking same question again and again, right? Escalate. That might be one way to tell the bot. And then what are the other ones? Like maybe some functional hooks in between that will keep checking what's going on with the bot, right? And then accordingly say that, oh, this is the point to escalate. Yeah, I think someone is saying the same thing. It's the compute cost. Like, I mean, those old models like GPT-3 and all, like those probably can be trained on your some very strong laptops as well. But the newer ones that are coming, they are very expensive. Like, so it's all going to be cost. Like you can use some hosted services like GCP, Oracle Cloud, and other clouds, and train it there. But again, it takes time and then resources to do it. I think most questions are around the same line. So this will be a good time to jump to the demo, right? Like see some of these things in action. And again, we'll come to the questions towards the end. So what I have here is on my local, I built two bots. One is through the classification model, right? And what this one does is I have this data.csv file, which has like it has text and label, right? This is not a very good view to let me open it in spreadsheet. So this is how it looks like. It has these are the label or intents that I want to handle. And there are not many, I think 10 intents, each with 10 utterances is what I started with, because I don't want it to take too much time, right, during the demo. So it will build fast, but in real world, you'll have a lot more utterances per label, right? And it's going to take a lot more time to build the model. So these are the questions they map to the intent. You collect this data, right? And once you have the data, then we are going to be training a model out of this. And then that model we are going to be using to identify the intent. We'll play with that. And what I did here is I also have a static another file where for each intent I have some static response configured. So whenever I ask a question, I should get some response. Now, what my bot is doing now, like there are two important files. One is training. Like I'm training a SVM model here, and once it's trained, it's gonna be storing it on a local file, right, with this name. And then in the inference, I'm just gonna use that model to execute the model. Like bot will do simple thing. First, call the SVM model and identify the intent label, and then pass that label to a function that is doing nothing but looking at the other file and generating a response, right? Like, and the response, if it knows the response, and if it's the logic is if the confidence is more than 0.4, give the response. If it's not, or if the response is not found, fall back to this static response, right? Now this one, let's do this. Let's run this. The first thing we'll do is build the model, right? So I run this, it's actually executing the data.csv. And it was so fast, right? Because literally I have like 100 lines in my data set, which is not the use case in production, but it worked. Now, if I do ls minus lh, this is the model that is built, right? Really small model. So now let's play with it. So if I say 3 inference is the one that is going to take user input and execute. Now I'm supporting the queries I'm supporting here is like, where is my order sort of thing, right? So where is my order? And what it could do, it could execute that model and said that the query, the model, like the intent is order status. Here is the confidence. And based on that, this is the response I configured, right? I could open my CSV file. This is what it says. Provide your order number and I'll check with the status. So it is working. Like I can try with other variations of this, like I can say my order is still identified, right? What happened to my order? I'm just trying random things, right? So in most cases it is able to, because it has order keyword and all, right? If I say what happened to my camera, right? It couldn't identify. I mean, it thinking it's order status, but the confidence is very low. And that's why we're not getting the response. So now, like the thing is, tomorrow you want to handle a new scenario. Like I can handle how to book an appointment. My model does not know, right? It's just incorrectly categorizing it. But it's very simple to change this, right? If you want to support this, what we got to do is we got to add some utterances here, like add some data for that. And luckily I maintain that data. We're just gonna quickly modify this and show in real action, right? So I added some more utterances for the appointment scheduling, right? And now if I train my model again, and then I execute the inference again. Now if I say, how do I book appointment, right? It could identify. Let's say the intent is appointment scheduling. The confidence is this, right? And it's giving a response. This is a very basic response, but this is something I have configured, right? Just to show you guys, I think the other model, if the data set was bigger, right, the training will take higher time. I have one more file. Uh, I'll start the build, right? Just to show you guys, it takes extra time. Right? This file is huge, like, I mean, not that huge again, like 10,000 lines or something, right? The bigger text and then corresponding intent. If I train with this, it's going to take like almost a minute or more to build this model again. Right? We'll let it build, and we can use that time to uh, start talking about the LLM bot. Right? It's still building in the background. You can see. So for the LLM bots, like I have two bots, and again, not very complicated ones I built, right, for demo. So this is one bot that I built where I said, hey, I'm just, all I'm doing is instantiating the OpenAI API, right? And with my keys and all, and asking it to complete the, like, generate the response. In prompt engineering, I'm using prompt engineering. I'm saying, hey, you're a customer support assistant for online e-commerce store specializes in electronics, fashion, home goods, something 50 frequently asked question. Rephrase the response to make it creative, right? And do not answer outside the FAQ. If the question is not covered, politely inform the user that you're not able to assist. So like we'll say, I gave it 50 question and answer. I can ask any variation of this question. It is going to be able to identify that I'm trying to ask this intent, right? Give me an answer. It won't give the exact answer because I asked it to rephrase, right? Rephrase and make it creative, right? So it's going to do that, and it is going to answer with all these things. It's that simple, right? And these prompts and all you can generate with the help of ChatGPT or other tools as well, right? Plus, like with this real use case, you can identify what are the FAQs. Your website might already have it. Just feed that data to the LLM bot, right? Add a simple code, like probably a few hours work, right? So here on this side, it could build the bot. Like I think it took more than a minute to build that bot, right? And if I do let's, it could build the model now, which is just built. Right? Let's play with our LLM based part and see if it's actually answering these FAQs or not, right? So I'll say Python 3 LLM FAQ CC. What should I ask? I can ask same question. How do I track my order? Right? Now see, it's giving a response, no problem, I'm here to help. This is not what I have configured for order, right? Where is my order? This is the response, but it could rephrase it to sort of make it more human-like response, right? And not just that, like I can try different, like what happened to my order, right? So it's still, it's sensing that, okay, I'm getting not happy, right? So it's still answering similar answer, but changing the wording, right? If I say something like, what did you do to my order? Yeah, I mean, yeah, it's repeated, but sometimes it'll say, oh, I apologize and all. So the answers are also creative. Like I just gave it one FAQ. I said, this is the type of question people will ask. It could find all the different variations of this that people might ask, right? And then come up with the response that looks like this. You can try with other queries as well. Like change my shipping address, right? So here also it's able to do that. Like it's saying, okay, give me the, right? So these, I mean, the one thing is it's so simple. Like you just took raw FAQs, like question answers, gave it to the LLM bot, right? And then you can ask all the variations of that question. You can get innovative response, right? And then also build flows out of it. Now, this one, and again, like I'm telling it very strictly that, hey, you only answer these questions, anything outside this, right? Don't answer. I can also sort of add a hookup here to escalate to the human agent in those scenarios, right? If they go outside this script. Then the last one I have is, right, and then we'll go all questions, is the FAQ. Like rather than passing the FAQs in a prompt engineering way, right? Like here, like this, you might have your FAQ in a database or in a spreadsheet or somewhere else, right? And you might want to integrate with that. Remember that multi-agent setup I was talking about, something like that, right? So in this example, I have my all my FAQs are here in this CSV file, FAQ CSV. Okay, I think again, it would be better if I use this. Yeah. So here, like now, wrong file. Sorry. Mm, am I in the wrong one? Okay, my bad. This is FAQ.csv. Yeah. So this is a typical database. Like this one is just a CSV file where I have a bunch of questions and the corresponding answer, right? Now this bot, what it's doing is it's looking up in this file to find the response, right, through a regular text match. And then once it finds the response in the file, which is the lookup is done here, right? Once it finds it, it's using LLM to rephrase the response, right? Please rephrase the following response. And you can also say how to, like, for example, here I'm saying like in a friendly and funny manner. So if I run this bot and let's play with this, let's ask something. Yeah, we'll ask the same question to this guy as well, right? 3 LLM bot for CSV. And I say, where is, yeah, I mean, it is pretty dumb because it's doing a text-based lookup. So I'm gonna stick to the script. Yeah, so see what it did. The answer I have configured is this, please provide your number. But so it could go look it up. It found this answer, passed it to LLM and rephrased it. And since I asked it to be friendly and funny, it is saying that, sure thing, can you give me your magical order number of yours, right? Similarly, we can see what else. How do I apply? I can say apply promo code. Sure thing, just pop the set, right? So now this is another one, like when you are talking, like when you are using prompt engineering, you can tell your bot how to respond. Like, I mean, funny is not the right way that you will be using for the production deployment. But again, you can choose like how you want it to be professional, you want it to be strict, all that can be configured here. So this goes back to my use case. I was saying, hey, you can integrate your LLM with the database and then use the LLM to rephrase the response, send it back to the user. I think that covers all the scenarios I had in mind. Right? I will now look at the questions and see. All right. Can you share the details of the architecture of this classification model? We just trained one more time. Architecture of the classification model. We just trained one more time. I do not understand this question. Maybe, Sai, are you referring to the model that I was showing you, or like in my particular example here, or in general, you're asking the internal architecture? I can check in this repo. Yeah, that can be done. Internal architecture. Okay. So, like, uh, how these models are stored internally, I think that's a really good question. And it sort of depends on the which model you choose. right? Activation function. Okay, I apologize. I'm not getting the question clearly, but let me like give some more context and see if that helps you, right? So the way these models are built and stored internally, it depends on the underlying type of model you choose, right? Like some models use spatial location, like they try to put data on different in a 2D, 3D graph and see the location from the center, right? Some other models have internal way of managing it. So if it's SVM versus random forest versus decision tree, that will decide which like how this model is internally built and stored. Why using if you can't allow model to be so creative only? So, let it some kind of domestic behavior. Yeah, sure. I mean, that is just a demo, right? You can play with these numbers. You're right. Temperature will control the creativity of the model, and you're gonna see what is the right value for your use case, right? So one thing to note is you won't just build something and deploy, right? You want to test with the prompts, like all these integrations very carefully. Even the prompts that you write, you might want to run multiple level of tests to make sure that it is adhering to the script you gave it. And also it's not trying to answer those random questions, right? Like not going to a scenario where it ends up selling something for a much lower price. So that has to be avoided. Can you show the overall workflow, including scenarios of classification model and part? Can you show the overall workflow, including the sections of classification model and LLM part? Or do you mean the code references or the hybrid approach? I really wish this was like a wise questions where I could ask clarification. This is getting somewhat difficult to figure out which section are you referring to. Can you show the overall workflow? Okay, I think it's, yeah, some questions I understand what you're saying. I can answer those. Some questions I do not understand the specific section that you're referring to. Uh, what will work out is maybe you can either comment on the YouTube video once it's uploaded, right, with some more context. What are you trying to get at? And I can try to answer those. Or we can explore some other mediums to sort of connect offline, and I can answer those. All the straightforward ones that I understand, I'll try to answer here. Apologies for not being able to figure out the exact question for you.
Thank
Sorry to interrupt you. I think we are having some audio issues. You are not clearly audible.
you.